Today I'd like to tell you about conversion factors, otherwise known as unit factors. Conversion factors, or unit factors, are fractions that are equivalent to 1. They're important because they'll help you to understand how to solve chemistry problems, and they'll also help you to see if you've perhaps gotten the right answer when you do solve a problem. This is Thinkercat. Anytime you see Thinkercat, it means that you have a question to answer. Since unit factors are fractions, we have to review a little bit about fractions before we start this lesson. So when you multiply fractions, you may recall that you multiply the numerators together, multiply the denominators together, but also if they have a common factor in the numerator of one fraction and the denominator of the other, you can cancel those. So my first example is 2/3 times 1/2. You have 2 in the numerator of one fraction and in the denominator of the other. 2 goes into 2 one time for each of those, so you cancel those out. You end up having 1/3 times 1/1, multiply the ones on top and the 3 times 1 on the bottom, and you get 1/3. Now again, to get that, what we did was we canceled the 2 here with the 2 there. 1 times 1 is 1 on the top, 3 times 1 on the bottom is 3. Okay, here's another example. 4x over 7 times 21 over x. They both have a factor of x. The x here is in the numerator, the x here is in the denominator. They can cancel out. 21 is actually 7 times 3. So 7 goes into 21 3 times. We can cancel the 7's, 1 there and 1 there. In the top you have 4 times 3, which is 12, because the 21 canceled with the 7, leaving us with 3. In the bottom we have 1 times 1, which is 1, and 12 over 1 is 12. So what you need to remember when we're working with unit factors is if you have the same factor in the numerator of one fraction and the denominator of another, they'll cancel. It's a really important concept. Okay, so here are a couple more fractions, but this time instead of just numbers or algebraic variables like x or y, we put some units in there. In the first fraction I have 24 inches over 1. The second fraction is 1 foot over 12 inches. If I want to multiply these, I do the same thing that I did with my other fractions. 12 goes into 12 one time, 12 goes into 24 twice. There's inches in the numerator of the left fraction and inches in the denominator of the right fraction, so they cancel. The inches cancel out, I'm left with feet. So 2 times 1 on the top is 2, 1 times 1 on the bottom is 1, and I've still got those feet units left. 2 feet over 1 is the same as 2 feet. So what I did here was I used what we call a unit factor to convert 24 inches into 2 feet. Let's look at the next example. What do you see in the next example that has units that you could cancel? Remember, Thinkercat's there, so you had to think about it. You see meters, the m in the top of the left fraction and in the bottom of the right fraction. Those m's cancel. So you take 5.4 times 100, which you could do on your calculator, but you could just move the decimal 2 to the right, and you would get 540. And then the meters canceled out, so we have centimeters. 1 times 1 on the bottom is still 1, and 540 centimeters over 1 is simply 540 centimeters. So what I did in this problem was converted 5.4 meters to centimeters by using the unit factor. 100 centimeters is equivalent to 1 meter. Anytime you have equivalent measurements, you can write those measurements as a unit factor which I sometimes call a conversion factor. So for example, we know that 12 inches is equivalent to 1 foot. I can write 12 inches over 1 foot as a fraction because 12 inches is equivalent to 12 inches. That fraction, 12 inches over 1 foot, is actually a conversion factor that's equivalent to the number 1. Now, anytime you multiply something by 1, it doesn't change the value of what you're multiplying it by, and that's something we'll look at in a little bit. So we have 12 inches over 1 foot. Is it possible to flip that over and have the reciprocal be a fraction that's also equivalent to 1? Take a moment, write the reciprocal of 12 inches over 1 foot, and think about that. Is that also equivalent to 1? If you answered yes, you're correct. 12 inches over 1 foot is equivalent to 1, and 1 foot over 12 inches, which is the reciprocal of that measurement, is also equivalent to 1. Anytime we have two units that are equal to one another, like 12 inches over 1 foot, we can write those units as two separate unit factors. The unit factors in this case are 12 inches over 1 foot and 1 foot over 12 inches. What I'd like you to do next is to write two unit factors for each of the following sets of equivalent measurements. I'll do the first one for you. The first one is 100 centimeters is equal to 1 meter. I can write that two different ways. 100 centimeters over 1 meter as a fraction, and 1 meter over 100 centimeters. It's your turn. I would like you to complete the next 3 problems. Take a minute and check your answers. So I'm sure most of you could convert 24 inches to 2 feet without using any kind of unit factor. That's something that you can easily solve in your head. But what if you wanted to know how many centimeters are in a cubit? Or if you've got 18 cubits, how many centimeters would that be? Or even more importantly, what if you have a patient and they need a certain amount of medicine and it's in a certain dosage and you need to know how much medicine to give that patient? By using unit factors, we can apply this method to problems like that, and we can have a really nice concrete way of solving problems that shows us if we've gotten the right answer, because our units will be there, and we know that if we got the right units, we probably solved the problem correctly. This saved me a lot of times in my physics and chemistry classes when I perhaps had no other idea how to solve a problem. I thought if I can at least use conversion factors, I know I'll get part of this solution correct. Let's try an example problem. You find an ancient Egyptian text that describes a box which is 22 cubits long. You hope to locate the box and bring it home in your carry-on bag, which is 55 centimeters long. Will the box fit in your carry-on? What I'd like you to do to start this problem is go back to slide number 9 and look at the unit factors that you wrote that are related to cubits and that are related to centimeters, and write down anything that you see that has cubits or centimeters as part of your unit factors that you wrote. Okay, hopefully you found these unit factors. 1 cubit, I'm just going to abbreviate cubit as CU for now, is equivalent to 18 inches. So we could write that as 1 cubit over 18 inches, or we could write it as 18 inches over 1 cubit. Now there's another conversion factor or unit factor that we saw back there, and the other unit factor was 2.54 centimeters is equivalent to 1 inch. I'm just going to kind of squeeze those in over here. So 2.54 centimeters is equivalent to 1 inch, and because we're writing unit factors, it can be flipped over as well. 1 inch is 2.54 centimeters. Okay, I want you to think of these as the puzzle pieces, and what we're trying to do is put a puzzle together with the correct pieces so that we start with cubits and we end with centimeters. Okay, so here's what we're going to do. We start with our 22 cubits. Now, in order to get this to work and the way we've been working with fractions, let's write 22 cubits as a fraction. Any whole number can be written as a fraction if you just put it over 1. 4 over 1 equals 4. 22 cubits over 1 equals 22 cubits. Now what I need to do is find a conversion factor or a set of conversion factors that I can multiply by this to get the desired answer, which in this case is centimeters. So I want to look for something that's going to cancel out the cubits and perhaps give me centimeters. What that means is, in order to cancel the cubits, I'm going to have cubits on the bottom of my next fraction to cancel the cubits that are in the numerator of the first fraction. So we look at our 4 unit factors that we wrote. Take a moment and find the one that has cubits on the bottom of the fraction. Did you find it? How about this one? 18 inches is equivalent to 1 cubit. Let's write that here. 18 inches, and actually what I'm going to do is switch that to purple, if I can erase. 18 inches is equivalent to 1 cubit. Okay, so I've used that conversion factor. I can cancel my cubits. If I would do the multiplication here, I would have my answer in inches. Now the trouble is, I don't need inches. I need centimeters. Do we have another conversion factor that will convert my inches to centimeters? Which one should I use? Well, you've kind of got 2 choices, right? We want inches and we want centimeters. So it has to be one of these 2 right here. And because we want the inches to cancel and our answer to be centimeters, to cancel inches in the numerator there, I'm going to need inches in the denominator here. That means I need this fraction. 2.54 centimeters is equivalent to 1 inch. The inches will cancel. And if you do this properly, the units that you get here are going to be the units that we were looking for, which is centimeters. So then all I need to do is pull up my calculator, multiply 22 times 18 times 2.54. My answer will be in centimeters. In the bottom, I have 1 times 1 times 1, which is just 1. So whatever I get when I multiply those together in centimeters is my answer. I can compare that with the 55 centimeters and see if my bag is big enough or not for my 22 cubit box. Okay, so you probably thought, well, cubits, whoever uses those, and why wouldn't I just lay my object next to my suitcase and see if it fit, and if it didn't, I'd go buy a bigger suitcase. You know, those are pretty good points. But what I was trying to show you is the way that we can solve problems using this method, and it's a very powerful way. So here's a maybe more practical problem, and this involves a medicine where it's a suspension, and you've got 5 milligrams of medicine present in each milliliter. Your patient needs 35 milligrams of the medicine. We want to know how many milliliters your patient should be given. Now, I'm sure that many of you are looking at this and saying, oh, I know the answer. I know right now what it is, and that's great. What I want to do is I want to show you how to use the unit factor method to solve this problem so that when we get more complicated problems where you can't see the answer immediately, when we have a little bit more difficult problems, that you'll be able to use this method to solve those problems. So when I look at this problem, I say, well, my patient needs 35 milligrams. That's kind of my starting point. And then if I look at the other things that are present here, the other numbers in the problem, I've got 5 milligrams of medicine present in each milliliter of the suspension. That actually is a unit factor, or can be written as a unit factor, because that's an equivalency. That's telling me there are 5 milligrams of the medicine in each 1 milliliter of the suspended medicine, of the suspension. So since I have that as an equivalency, what I want you to do now is take a moment and write 2 unit factors using this equivalency. Okay, hopefully you wrote this. 5.0 milligrams for each 1 milliliter. Or you can flip it over, of course, 1 milliliter for each 5.0 milligrams. Okay, so we've taken care of the milligrams and the milliliters by writing our conversion factor. We're going to start with our 35 milligrams. That's really our given value in this problem. And what are we trying to find? We're trying to find milliliters. So essentially what we want to do is convert our 35 milligrams, which we're going to start by writing as a fraction by putting it over 1. We want to convert that to milliliters. Now we have 2 conversion factors we can use. We have number 1 and number 2. Which one should we use? Number 1 or number 2? If you chose number 2, you're correct. The reason I would choose number 2 is because when I write that here, 1 milliliter over 5.0 milligrams, I can see that my milligrams are going to cancel out. I'll take 35 times 1, which is 35, divided by 1 times 5, which is 5. 35 divided by 5 is 7. And notice my units here. I have milliliters, which is exactly what I was supposed to find. So my answer, and if I want to use correct significant figures here, is 7.0 milliliters. What would happen if I chose the other one? Let's try it and see. I want to show you how you would know that you got the wrong answer if you used the other conversion factor. Here's what would happen. You'd have your 35 milligrams over 1, and you chose the other conversion factor. So you wrote 5.0 milligrams over 1 milliliter. Now, doing it this way, you would think, oh, I should take 35 times 5 to get my answer. But when you look at the units, nothing's going to cancel out. You're taking milligrams times milligrams on the top, which really is milligrams squared, and you're getting milliliters on the bottom. You're not going to get the units that you want at all. So by doing the conversion factor method, we can see that we got the right answer because our units are correct. And it's really, really important to write those units down. So when you're solving these problems, please just don't punch it into your calculator and try and add, subtract, multiply, and divide to see which one seems right. But write it down on a piece of paper, number the problems when you're doing your homework, so that then you can refer back to them and do this in a notebook so you can refer back to them later when you're doing another problem and trying to figure it out. I hope you have a great day, and thanks for listening.